Hello, everyone. I'm not sure if you can see me yet. We're just sending out the link to everybody. They'll be getting it shortly, so stay tuned. We'll start maybe in 5 minutes or so. So get your drink, get ready, and we'll resume shortly.
Testing audio. Okay.
Hey, everyone.
Hello, Dean. How are
How
you
are you?
for joining us?
No problem. You're in your apartment?
Yeah,
Nice.
it's been like that for quite a while now.
Yep. Oh, we're live on YouTube too? Cool.
Yeah, we are live now. People is listening to our conversation.
Great.
Yeah, we'll get it started pretty soon.
Okay. So how do you want to run this? Do you want me to, I only have a few remarks at the opening, and then you want me to just sort of hang around, right?
Yeah, I'd love for you to see what we've been working on and the progress. I'll introduce you. Yeah.
Perfect.
Yeah. So for everyone who's on live YouTube, we will get started pretty soon. Just some logistic details and we'll be good. We've got 75 people watching on the stream now.
That's awesome.
Yes. So welcome everybody. We'll be waiting just a couple more minutes. We'll get started.
Hey, Sasha.
Hi, Dean. Yep.
How are you doing?
Doing well.
Good.
Excited for the event today.
Cool. No, this is great. Wow. Would have been a lot more fun in person. Let me just tell you guys all that right now.
Yeah.
Couldn't agree more. Yeah, but I guess it's a sort of a sign of the times, right?
Yeah.
So how are we doing? Shall we?
Sure. It's up to you. And then I guess, do you want me to just throw it back to you, right, when I'm done? So
Yeah.
okay.
I think we have.
Yeah, I guess I don't have very much. Yeah.
Have everything ready now?
You guys need a Hyperloop background, actually. That's what you're missing.
we did try that, but doesn't look as good as we want it to be.
Okay.
Yeah.
Unfortunately, my shirt is at school still.
Okay, let's get to it then. Let's get it started. Sounds good.
Okay.
Okay, so hello everyone. Welcome to the U of T Hyperloop Virtual Symposium. First, I'd like to thank our sponsors, partners, U of T faculty and staff, friends, family, and teammates for joining us today. I'm thrilled to be here to host this event for you. And as we all know, these are unprecedented times for us all. And I wish that you and your family are safe. So it is in moments like this that we could take this opportunity to stop, reflect, and refocus our efforts. So today is about sharing the progress and work of a one-year journey of tireless and devoted work towards sustainable high-speed transportation. Today is about what a combined effort of 200 engineering and business students have accomplished in the last 2 semesters. So to start us off, I'd like to introduce someone who has been an early supporter of the team and also has provided valuable advice to us, the Dean of the Faculty of Engineering at the University of Toronto, Christopher Yett.
Great. Thanks, Juan. Have you got me full screen? Let's see. So thanks, Juan, for the invitation to attend tonight. Virtually, as I was saying earlier, I really wish we were all there in person. This is, as you mentioned, unprecedented times, but I think it's interesting times. We still continue to work together and I think interact just as well in this virtual world. As Juan mentioned, I am very proud to be the Dean of the Faculty of Applied Science and Engineering here at the University of Toronto, and particularly proud of all the clubs we have and realizing that we have over nearly 100 clubs and teams at U of T and in the engineering faculty itself. And it's so exciting to hear about how our students see this as being, almost the most valuable part about U of T engineering, more so than even the classes, I think, is the clubs and the events and the activities that really build our community together. But what's been really impressive for me is just like how fast, and maybe that's the context of the Hyperloop in a sense, is how fast it has grown over the past, like, frankly, a year. My notes actually said you had more than like just 100, but you just said you have over 200. And it's been amazing to see how it's grown, how quickly and how exciting this opportunity has, and how much you've been able to reach out and grow sponsorship and support from the broader community. The fact that you've reached out through the Canadian Hyperloop Consortium to partner institutions and partner universities, building these big opportunities across the whole region. I think this is super exciting for us. Really shows the initiative and the enthusiasm, not only of this team of UT Engineering, but just how well you've brought this community together. And full shout out, full congratulations to all the hard work of yourself, Sasha, everybody on the core team. The ability to pull together this team and just really make it such a huge success over such a short period of time. It's just incredible. It mirrors really what this technology is all about, right? The next great form of human transportation. I'm super excited, super keen to see and hear about what the various teams have been able to do over the past year. Such an exciting opportunity, such tremendous potential. This really is a team that celebrates the excellence and the engagement and just the community that we have within our faculty. As I said before, I'm super excited to see what the 4 teams have pulled together tonight. I'm keen to be here for the next couple hours and just really hear about your opportunities, where you've got to, and frankly, what I can do, what the faculty can do, what the University, U of T can do, what the other universities can do, what we can do to help make your projects a big success. So I know I'm excited. I'm super excited to see what everyone's been doing. So, I kind of want to get right to the presentation. So again, congratulations on, this initiative, how fast it's launched. how much excitement's been in the community, and really just keep up the good work, and let's see what you guys have been able to pull off. So where do you go? Congrats, Juan. Oh, you're muted.
Sorry, my bad. I was. So I'd say thank you, Ding. Yes, it's been quite a journey. And now before we jump into the designs and all the great stuff that we have to show you today, I would like to jump back to when I found out about the Hyperloop and the competition. So when I first came across a video of the Hyperloop SpaceX competition back in February 2019, I saw teams from around the world working on really exciting technology and sending these pods speeding down a tube at insane speeds. So most of all, I saw an opportunity. I saw an opportunity to showcase the engineering skills that we have here at U of T on a global scale. An opportunity to leave a legacy to the new generation of world-class innovators right here at U of T. So when you see something that is inspiring and you feel so passionate about, you just do it. So I started the team, and we haven't really seen. So let me share my screen now. We haven't really seen for more than 100 years a major innovation in the transportation industry. For a plane to get from San Francisco to LA or from Toronto to Montreal, the actual traveling time is less than an hour. But we all know that airplane travel is a convoluted process. So if we think about it for a second, the top 10 busiest air routes are just domestic. So we're here to find a more sustainable and more efficient way of transport. So high-speed trains have been an alternative for many years, but they face limitations due to drag and high friction. And Elon Musk in 2012 published a white paper on proposing a solution to this problem, and that was the Hyperloop. So the Hyperloop are pressurized capsules which levitate and are electrically propelled within a low pressure tube. The low pressure tube allows for almost no drag, zero drag, almost there. And the levitating technology allows for close to zero friction. So what makes this concept sustainable are two main reasons. First, the low energy consumption due to negligible drag. And to understand the significance, bear in mind that the energy consumed due to air drag has a cubic relationship. So second reason, thanks to the levitating technology, we face almost no resistance to movement, meaning low friction. So a few impulses along the pod trajectory would serve to take the pod from point A to point B. If you think about it like on a spaceship in outer space, if you apply some thrust to it, it would infinitely move if no braking force is applied. So the purpose of the Hyperloop is to take an enormous leap where in transportation, where cities are closer together and people are more connected than ever before. So you may wonder, who's actually making this a reality? And the answer to that is, as you may guess, is brilliant students around the world. So who better to speak to it than one of them? I'd like to introduce someone who is the technical director, incoming intern at Tesla, and great friend of mine, Sasha Rudolph.
Thanks, Juan, for the great introduction. So I'd like to talk a little bit more about what this competition is all about, what the SpaceX competition has become over the last few years. So I'll just share my screen. oops, wrong screen. There, sorry. So as you may imagine, there are many technical as well as institutional challenges that need to be overcome to accomplish such a large infrastructure project. It would take smart people from around the world to solve the challenges of safety, of reliability, and viability in actually developing a new solution. And that's what this SpaceX Hyperloop competition is all about. Through this competition, Elon Musk has inspired bright minds from around the world to get excited about sustainable, high-speed transportation. Since launching in 2015, the competition has become one of the leading student engineering competitions and seen the rise of a new generation of engineers who are excited about solving this problem. Now, I'd like to explain a little bit more about what the competition entails. The objective is really simple. Build the fastest pod to run at the 1 kilometer tube outside the SpaceX headquarters in LA. Throughout the competition, student teams must meet a series of deliverables in order to design, build a Hyperloop prototype that is both safe and fast. So the competition starts with the release of design specifications. From there, over 1,000 teams submit preliminary designs. SpaceX engineers then review these designs, looking not only at the engineering, but whether or not the team actually has what it takes to execute and actually build the pod. From there, about 20 teams are selected and invited to build their pods and travel to LA. The competition runs over 1 week, where teams are put through a grueling 150 safety tests to ensure the pod will not damage the tube or harm anyone. These safety tests are so intense that on average, only 4 pods are deemed to have been engineered and manufactured to SpaceX standards. And these pods are then allowed to erase their pods down the 1 kilometer tube. So as much as these pods have to go fast, teams have to convince the SpaceX engineers that their pod is reliable and that they've done the right engineering analysis. And that's essentially it. That's the SpaceX competition that has inspired thousands of students from around the world to get excited about high-speed, sustainable transportation. So now I'll pass it back to Juan to continue the presentation.
Thank you, Sasha. And I'm going to share my screen too. Okay, so Sasha mentioned and Elon agrees, this is not one person's job. And when I started the team, I grabbed 2 of my friends in the material science department, who you will get to know very soon. And over the summer of 2019, the team grew to be from 2 people to 30 people. And by the end of the first semester, we had over 80 actively engaged students and more than 200 general members from UTHT, Schulich School of Business, and OCAD. Our team set up developing the resources that we needed to be successful. So from developing a team structure to developing industry partners like Hatch and many other sponsors to fundraise about $75,000. And most of all, our team set up to build our first pod, research technologies for next pod, and build the test track to collaborate with all the teams in Ontario. So allow me to say this, we are entrepreneurial, we're motivated, and we're eager to change the world for the better. We ambition to advance the technology for a sustainable future in transportation. We are the University of Toronto Hyperloop team. So I'm not gonna get into what we have built or pod 1. Well, we're in progress of building it, but due to unforeseen situations. But this is our pod 1. Pod 1 was originally designed to run at the 1 kilometer SpaceX competition. However, with the delays in that competition, we set our sights in the Canadian Hyperloop competition. So we designed our pod to contain all its energy and run entirely autonomously, and of course, be very safe. So the design constraints are fairly simple, as you can see from the image. It's an aluminum I-beam and 2 aluminum plates that the pod can use as a track. All of this is then enclosed in a central 2-meter diameter steel tube that is pressurized to 1 millibar. It's a very low pressure. So that is one of the key facts about the Hyperloop. The tube where it runs is very low pressure. So the pod then will run autonomously and achieve its top speed and then brake. So given the constraints, our team built the pod entirely from the ground up. We did not have previous years to turn to, and it was up to us to find the answers, try things out, and find our way. And this is what we come up with. So now I want to show you a little narrative, a quick video of our pod. And I'd like to introduce Jovan Poole, who is the structure's lead, co-founder, and also incoming intern at Safran Technologies. So
thanks, Juan.
You ready?
Yep. At the start of the run, with 16.8 kilowatt hours stored in our custom lithium-ion battery pack, our pod engages its electric motor to apply 0.2 Gs of acceleration. The pod takes off, fully autonomously, and hurtles down the track, reaching a speed of 250 kilometers per hour. This whole time, our control systems are monitoring the health of the pod, sending the data back to our pilot station and tracking position using the Vector Nav IMU. Once the pod reaches the braking position, our 4 Cobalt braking units autonomously clamp down on the rail, applying 1,800 newtons of braking force, bringing the pod to a complete stop in the last 150 meters. At this point, the pod depressurizes and signals to the pilot station that it is safe to approach. And that, ladies and gentlemen, is Pod 1, presented by the brilliant engineers of UTHT.
Awesome, Don. Thank you very much. So, continue with the presentation. To accomplish all of this, our engineering students volunteer over 10 hours per week on average. And we had the opportunity to learn engineering, management, and professional skills that go into building a fully integrated multidisciplinary engineering project of such a large scale. So it was not easy, and we are incredibly proud of the effort that everyone put in to get us here. Although it's not finished, once we are allowed back, we are going to put all our effort into the shops and take all our parts, integrate them, and build the rest of this pod. So it's worth to mention that, Pod 1 was built under SpaceX requirements, and it will run at the Canadian Hyperloop competition. This competition is run by the Canadian Hyperloop Consortium, which is a student-run organization led by 6 universities in Ontario: University of Toronto, Waterloo, Queen's, UWindsor, McMaster, and Ryerson. The consortium has been giving it a go-ahead to build a 150-meter track at Downsview Park, and if everything goes back to normal soon, we expect to host this competition by the end of August 2020. So, as you may think, if there is a Pod 1, there must be a Pod 2. So for that, our R&D division is developing the next generation of levitating and propulsion technologies. And I'd like to introduce someone who's an innovator, incoming intern at Intel, and chief engineer, Pod 1, in R&D, Jeremy.
Hi, everyone. I'm Jeremy. I'm the chief engineer of the R&D team. So here, I'm just sharing my screen. So the R&D team, we're a team of 15 dedicated students from engineering and physics. We're split into 3 ongoing projects, and we have support and advice from professors and grad students from MIT, Ohio State University, and U of T. So our first semester of when we started out was really just looking at a lot of different aspects of Hyperloop and seeing where we wanted to focus our resources, since we're a smaller team. And starting second semester, we really decided that we wanted to focus on 2 areas of interest. So that's contactless propulsion and efficient and stable levitation. So a friction drive Hyperloop is not really scalable over 500 kilometers per hour. And to make a sustainable Hyperloop system that can go full scale at speeds of up to 1,000 kilometers per hour, you really need these 2 technologies as a basis. So starting with contactless propulsion, we have been developing a linear induction motor. As you can see in the middle picture, or in the bottom left picture here, a linear induction motor is basically an AC induction motor rolled out, and then you put it on both sides of the track in the middle picture here. So this is a technology used by the top Hyperloop teams and companies. Second and third place in the 2019 SpaceX competition used this technology. Up in the top here, you see some initial simulations of our linear induction motor. So our first prototype of this is nearly complete. It was put on pause due to the pandemic, but as soon as things start up again, we're going to complete it very quickly and then use what we learned to implement a full-scale linear induction motor in pod 2. So the next technology we're looking at, electrodynamic suspension. This is the most stable form of magnetic suspension. It's much safer than any other form. And to achieve it, you need to use a hotback array, which if you see in the top picture here, it's basically an arrangement of magnets that optimizes the magnetic field on one side. So it basically doubles it. And with these strong magnetic fields, you can levitate basically passively at high speeds. It's stable, efficient, and very scalable. And when looking into many different ways of applying this design, we actually invented a completely new technology. So visit the R&D breakout room to learn more about that. And with that technology, we have a proof of concept prototype. So a small scale prototype that is almost complete, put on pause once again, but we will be getting results from it as soon as things start up again. So with these projects, we really want to have the flexibility to research, develop, and prototype new and innovative ideas, and basically anything that we see can be applicable to scalable Hyperloop technology. So next year, we're going to continue developing this levitation technology that is completely new. And we're also going to start looking at our third project, or continue looking at our third project, the transverse flux linear induction motor. And this is a design we're looking at that can produce levitation, stability, and guidance forces all in one. So hopefully it will be able to be used on future pods. We're also looking at scalable infrastructure and vacuum tubes. So those are some projects that might pop up next year. So with all this, we're already at the forefront of Hyperloop in our first year. And these future projects will allow us to be a top team in our second year. And we have a very exciting future ahead of us. And with that, I'd like to hand it back to our team leader, Juan.
Thank you, Jeremy. I'm gonna share my screen too, sorry. So thank you again, Jeremy. I really appreciate that. And our R&D division will not only propel us to win in the first place in the Hyperloop competition, but when they are developing the technology, they have in mind scalability. And that is something that I'd like to stress, and I want you to take away from this presentation. So that is, we're not just defined by a competition. We think of the future as something we can shape. And our technological advancements in levitation and propulsion are moving towards solving the current Hyperloop problem at high speeds. The technology we display has the ultimate purpose to make sustainable transportation at high speeds a reality. So I can't think of a better way to picture the future than picturing the portal or a Hyperloop station. So please enjoy this video of our virtual reality renders produced by our students at the U of T Daniels Faculty of Architecture. So here, engineering meets design for accessibility and innovation. We acknowledge that high volumes of people and cargo will interact with the station, so we're working to incorporate those innovative ways to streamline all these processes. And the person who has been leading this initiative is Rick Schutt, and he provided us with all this fancy stuff, how to think about the future and the future of the infrastructure, the future of how a Hyperloop station is going to look like. So as you can see, we are a big team with diverse backgrounds, and we share a passion for engineering and problem solving. The competitive advantage of our team is in its people, because they are building Pole 1. They fundraised thousands of dollars, and they are advancing mind-blowing technology. They are also thinking about the future. So before I move on to the next phase, I'd like to point out that it seems like the video didn't play. So if you want to see what the infrastructure team is doing, come and check out our breakout rooms. So from all this experience, I'd like to highlight some testimonies from our team members, and I'd like to bring them to this conversation. So let me introduce Matthew Tully. He is the software chief engineer for Pod 1.
Great. Thanks, Juan. Thanks for the introduction. So yes, as Juan said, my name is Mathieu, and I'm the software lead for UTHT. And like many of the other leads, I was brought on last summer, and I was immediately captivated by the team's motivation and genuine curiosity to solve problems and advance this really cutting edge technology. Since then, over the past 8 months, I've really thoroughly enjoyed and really benefited from my experience with the team. It's been incredibly rewarding to solve problems with your friends and apply that classroom learning, not for grades, but really just for the fun of it. So that's really been fun and sort of a refreshing take on the engineering challenges we face. As the leader of the software team, I was challenged with managing a 30-person team, but that ended up being a really smooth process. And I really attribute that to my members and their want to be there, their curiosity to solve problems. And so that was a really refreshing take on sort of this group project that, normally sometimes you get students that might not be as motivated, but really we had a full 30-person team fully motivated to solve these problems. And that was really, really fun to sort of engage with. Now, what's great about the software team as well is not just how multidisciplinary we are. We have students from industrial engineering all the way to computer engineering, but also the broad range of problems we try to solve. We solve everything from computer networks to control systems to software optimization and hardware integration. So really our members get sort of this broad spectrum of problems to solve and undergo. And that really, it's great as compared to, traditionally in courses, you can kind of get tunnel visioned on specific applications and specific projects. So it's really fun as a software developer even to sort of be incorporated in sort of all aspects of this technology. And that's really been an interesting challenge for all of us to sort of undertake. Now, again, with courses, most of the times you're given this problem definition. You're given sort of a skeleton solution and then sort of asked to fill in the details and fill in the blanks. But here in this application with Hyperloop, we're really starting from ground zero. We have to define the problems ourselves. We have to define that skeleton solution ourselves, and then sort of fill in the blanks. So for once, we're kind of like the teachers, so to speak. And this was really a new challenging for me. I really had to work hard to guide my team to sort of devising these solutions to the many problems and bringing all the many components of our software system together, connecting the control panel to our control system and making sure that all the sensors are communicating at high enough speeds and nothing is going down at any moment. So this has really been a tough challenge and really been fun to work on with my team. And all of this has sort of really felt like the culmination of my undergraduate education. Identifying problems is easy, but solving them turns out to be pretty hard. So, breaking down the problem and building it back up from first principles. This is lessons learned from my first year APS courses, defining milestones and, designing a large scale software system. This is sort of the culmination of all the software projects and courses I've taken through the past 4 years. So really this has been a great problem for me and for all my students to engage with. And I'm really proud of my students for how they performed in this regard. And truly this team and this project has exceeded all my expectations. And I really couldn't have asked for a better group of people to sort of undertake this massive challenge and do this throughout the year with. So for everyone on the team and everyone listening, I thank all of you. And with that, I'll pass it back to you, Juan.
Thank you, Matthew. Thank you for doing the great work, managing such a big team and bringing those industry standards to the team workflow. So now let me introduce Gloria Vitas. She's our composites and material science specialist.
Thank you, Juan. So I joined the Hyperloop team last summer because I found the idea and design challenges of a Hyperloop pod very interesting, and I wanted to be part of a larger scale interdisciplinary engineering project such as this. So I'm both on the propulsion and the structures team, and I'm helping manufacture the shell of the pod. So this includes creating several molds and working with a wide range of materials and manufacturing methods. So this includes from fiberglass to epoxy, CNC milling to wet layup. However, this process is currently on hold due to the pandemic. So we are now focusing on simulating the forces on the shell and using that information to better plan out and optimize the carbon fiber and honeycomb layers. By joining and being part of the Hyperloop team, I have gained a lot of hands-on experience with manufacturing and simulations that I otherwise would not have gotten in a classroom setting. And I also got to apply concepts that I learned in courses in practical applications. This experience has also been really useful to talk about in job interviews. By being part of the Hyperloop team, I have gotten to observe and experience the teamwork that goes into making a project of this scale like this work, and have gotten to be part of this larger community. So I'll pass it back to Juan now.
Thank you, Gloria, very much. And I work closely with Gloria and the structures lead, Joan Poole, on manufacturing the shell of this pod. And I can tell the can-do attitude and the positive attitude. It's really admirable and something that we should keep that up. And Gloria has been a great example of that. So last but not least, let me introduce Ashley Henry. And she's our electrical powertrain engineer.
Yeah, hi. Thanks, Juan, for the introduction. Well, I'm Ashley. I'm in my third year of chemical engineering, and I joined the Energy Systems Division of UT a while back. It's been about a year now. Since then, I've been working on studying electrical safety systems and controls for the pod and designing battery management systems for a powertrain. And when I first joined, this was all pretty foreign to me, and it was worrisome for me at first to be joining a really high-end team with, little to offer. And I imagine some new students and some people watching today may feel the same way. But then soon enough, my involvement in UTHT is what landed me my internship. I learned from my teammates at UTHT that your conceptual knowledge doesn't define your skill as an engineer. In fact, there was, when the team was forming, none of us really understood even what Hyperloop was to begin with. just like Matthew said, we lacked much information that would normally be available to us, like previous designs, prior research, any type of backbone that we could use to start designing. We were forced to start from the bottom, but we took that challenge. And what's interesting about the company that hired me and many other recruiting firms is that they value students with that initiative. And just students that showcase that motivation to take on newborn ideas. I landed an internship at Kinetrics, which is a research and engineering consulting company for nuclear energy. And they were not excited about my chem-eng courses or my prior research experience. They were fixated on UTHT. They knew that that Hyperloop was a big deal, that it was soon to emerge and change the course of transportation. And they knew that students involved in Hyperloop are really getting the means to practice real engineering. It's there to test, can you really work with cross-disciplinary teams? Can you adjust and amplify your team's work? I ended up learning a lot of new things that I never grabbed in my undergrad by working with ECE teammates, compiling research, and engaging in meetings. UTHT really taught me how to manage a design problem so that I can make consistent effort. And now I know how to approach a design bigger than myself, like my new internship. I'll be working for some of the largest nuclear plants in Canada. In the end, being a passionate engineer guides you to these big opportunities, and UTHT is a great start for that. If you ever wanted to know how well you can apply your engineering background, yeah, this is the place. With that, I'll hand it back to Juan.
Thank you, Ashley. And this is very, very inspiring. And one of the things, your words are things like truly make us and really make me happy. The opportunities that arise because of the work done at UTHT are incredibly rewarding. And so trust me, we'll continue to do so. And I'd like to bring back Sasha, who is going to help me describe our plans for next year and what is coming.
Thanks, Juan. As Juan mentioned, we're all very proud about the work that this team has accomplished over this year. In the face of uncertainty, we've created a new design team and really established a solid foundation for the years to come. So I'm very proud about the work that we've all done. And this first year was a part of a 3-year strategic plan that we created in order to get this team off the ground. So now I'm going to dive into what's happening in year 2, in the year that's coming, 2020 to 2021. Talk a little bit about what our plans are and what opportunities lie ahead. So let me just share my screen. Perfect. Well, so first and foremost, I'd like to mention that we're going to complete the manufacturing of Pod 1. Once we're allowed back on campus, our students will be hard at work completing the rest of the pod and picking up where we left off since the pandemic happened. It's been quite a delay in our manufacturing process. We had all our parts ready and we're about to dive in. So now it's kind of a question mark as to when we'll have an opportunity to get back on campus and finish that. But once Pod 1 is done, we'll then be moving on to our next set of goals. And this year has really been an amazing opportunity to learn for all of us, as you heard from the other teammates. And our plan for this next year is to apply the lessons that we've learned and really to make this team run smoother, to produce even better designs. So I'm very excited about what we're going to do by applying the lessons that we've learned. Our focus for this year is going to be on pushing the capabilities of transportation technology. I'm really excited about all of the designs that our team's going to come up with and the ways that we're going to contribute to scalable Hyperloop technology. And of course, we're going to continue to work on developing more partnerships with industry members to share the work that we do and really bring our designs to life. We have 3 projects on the go. for the coming year. The first one is Pod 2. Pod 2 is going to be a fully contactless levitating pod. There are a lot of challenges that come with this, but the key to our Pod 2 is that we'll be incorporating the technology that our R&D team has already prototyped. So we have one step ahead of the technology, and we're really excited to start bringing that cutting edge technology and integrating it into a full scale Hyperloop prototype. Next, our R&D team will be moving on to develop the version 2 of a lot of their existing projects, as well as developing new projects. So as Jeremy mentioned, they have the opportunity to sort of take different challenges and pieces of the puzzle and solve them. So I'm really excited about the projects that they have this year. And of course, our infrastructure team. Our infrastructure team is going to continue to look at what full-scale Hyperloop infrastructure looks like, what it feels like, and how it functions. And I think that with these 3 projects, our team will be able to continue to develop the next generation of innovators. And so I welcome you to join that, to become a part of our journey and to really take advantage of the opportunities that we have in the year to come. None of this would be possible without the brilliant minds of the students and the great partnerships we have with industry. In terms of student opportunities, Pod 2 is going to be awesome. So we have, in the next coming year, we're going to be posting a lot of new job opportunities or posting opportunities. So we have a lot of leadership because some of our team is now going to be moving to PEY and graduating. So if you're interested in leadership, something similar to what Matt mentioned, we have a lot of roles for you, as well as diving deeper into engineering problems and sort of owning your scope and really honing a technical skill. There are a lot of engineering specialist roles. As well, this is something that not a lot of people know, but we are open to first and second years to join in the sort of like an intern-like role. And this year, it's been amazing to see some of our first and second year students come onto the team and really become a driving force. So I welcome you to apply, whether you're a graduate student, an undergraduate student, join the team. And if you are interested, I highly encourage you to start off by joining the breakout sessions after this live stream. If you're watching, that's really the best way to get a sense of the team, to talk to the leads, understand what their challenges have been, what's coming in the year to come. So if you're interested, definitely go, and also stay tuned in the coming weeks for all the postings we'll be making. In terms of partnerships, if you're a company and you're interested in getting involved with the team, there are a lot of ways that you can do that. Number one is financial support. You can also donate parts, materials, and services, as well as mentor the team. There are a lot of benefits when it comes to partnering with the team. So first is access to R&D, whether that's having us use your technology and integrating it directly into our pod, or just being aware of the kind of projects and research that we're doing. As well, you have the opportunity to connect your brand with the future of transportation. Our marketing team is working really hard on finding ways to tell the story of our team. And this is an opportunity to become a part of that story and really follow us along with your journey and associate your brand with it. So we welcome you to join that. As well, it's an opportunity to get to know top students. As you heard from the testimonials, and I can speak to this having worked firsthand with a lot of this team, these are like really the top of the class. They're amazing students and they work really well in high performing, high functioning teams. So they're definitely people that you want to have on your team, joining your company. And through sponsoring the team, you have the opportunity to do that. As well, through our mentorship programs, you have the opportunity to really establish deep connections with students, pass on the best practices, and really share the experience of having done a lot of these challenges before. So I welcome you to partner. And now I'd like to take the moment to sort of thank our existing partners and all the people that sort of really enabled us to give this opportunity to so many students on campus. First, the University of Toronto Faculty of Engineering has been amazing. They supported us early on Especially, I'd like to mention the ECE department, the MIE department, as well as MSE. So that's electrical and computer, the mechanical, and also the materials. These three departments have been really supportive of us, taking the risk to support a team that has no prior history on campus. And so we thank you for your early support. As well, we partnered with Hatch, and we're very grateful for their engineering mentorship, sort of helping us establish best practices, and as well as financial support. They've been a really great partner. I'm going to go a little bit one by one, but Cobalt has been awesome. So this is a company out of BC. They make industrial braking and industrial brakes, and they've supplied us with custom braking units for our pod. And that's really like a safety critical system. And it was great to work with them in developing sort of the design specs. And a lot of our team had the opportunity to work directly with them and find out what goes into professional engineering projects. And the last one I'd like to call out specifically is BRS. So Big River Steel, they're a company that provided us with special electrical grade steel that is critical to making our R&D prototypes. So it's great stuff for a lot of the electromagnetics, and they sponsored us very early on and provided us with the material we need to be successful. We're really like, we feel very fortunate about, you know, in our first year having been successful with our sponsorship. And I'd just like to thank everybody for contributing and taking a part in our journey to raise over 75K in cash and parts to really enable this opportunity for all these students. And I think this is a great opportunity for, you know, companies and for students and everyone to get involved and join in engineering the future of sustainable transportation. Stepping away from partners now, I know that, you know, a lot of us make a lot of sacrifices to be on this team. We have all worked very hard to make this come true and really get this team off the ground. And a huge thank you goes out to all of the faculty who's helped us, all of our friends, our family, as well as all of the members of the team. So, you know, I thank you for listening to our upcoming year. And I also thank you for sort of participating in this live stream. And then the last thank you is a big thank you to everybody on the team. It's been a really amazing year. So I'd like to now pass it back to Juan to sort of wrap it up. And I think we have some good breakout sessions coming.
Thank you, Sasha. Yeah, and as you said, it's been quite a year, plenty of experiences. We're all very happy, and a huge thank for the team. It's all on them. And it's been great, and you just make me so proud, and I'm so happy that this happened. So now that concludes our presentation, this presentation portion of the symposium. And we have set up 10 breakout rooms from all leads. And before you guys go into the breakout rooms, I noticed that I didn't share the infrastructure video, so I'm going to share it now. And if you can stick around for like five seconds, it will be great. And you get to see some of the things we've worked on and what is coming. So it's 2 videos. This is more like a walkthrough of our station. This is coming up. You will see these videos pretty soon, and we're making these virtual renders to make a VR experience out of this, of our next Hyperloop station. This is one of them. And if you didn't see, this is our promotional video. It shows clearly how the station looks like from the outside. Sorry, I meant to show this before, but you can enjoy it now. So thanks again. Thank you very much for joining us. The real fun begins now. Please join our breakout rooms. We'll send out an email, and also you can go to UTHT.ca to check out the links to the Zoom rooms. So we'll stick around for a bit if you need some direction and some guidance on where to go.
I'm gonna try and get I'm gonna pull up the website now and kind of show everyone how to get into the breakout sessions. So let me just make sure I can share. Here. So if you go to, can you see my screen?
Yes.
Perfect. So if you go to utht.ca/symposium, we have set up a list of all the breakout rooms. Give us a second to start the home base. We'll have to end the stream and we'll get that one started. Otherwise, if you're interested in joining the team, there's a recruitment session. You can get in there, talk to the team about like what the next steps are, how to recruit, etc. We've got the partnerships business team. So if you're interested in sponsoring the team, or you just want to find out about like what goes into the business side of UTHT. There's a lot of logistics, marketing, all of these sort of things that go into making this possible. Then I'll go through, we've got a bunch of our sort of pod 1 teams here. So we've got pod 1 electronics. There's a little description. Rutwick's great. Jump in there, talk to them about sort of the hardware and like embedded systems on our pod. We've got energy systems, so that's Rakib. All about the high and low voltage systems of our pod. I encourage you to go check it out. Pod 1 software, that's really good. You saw Matt talk already, but you jump in there, talk to him more about his team. Propulsion, again, we've got Javin and Tony, that they designed all of the propulsion systems, so include the electric motor design and a lot of sort of that powertrain and the stability system. So jump in there, talk to them. And then structures, you heard Jovan, now you get to see Jovan. And he worked on a lot of the mechanical design, looking at the outside of the shell, all the aerodynamics, as well as the frame. Pod 1 braking, we've got Anton and Oris will be in there as well. There's some great stuff. So you can talk to them about the braking system, high pressure. They're doing with a lot of cool pneumatics. It's pretty awesome. As well as R&D. There's an R&D one. I skipped it because I was doing pod 1. But hop in there and talk to Jeremy about the projects. I think he's going to talk a little bit about the sort of moonshot project they've been working on. I encourage you to go in there and check that one out. So yeah, I encourage you to jump in here, join the students, start talking with everybody about their design. So again, that's utht.ca/symposium. Or you can just go to utht.ca and you'll see it there. Yeah, oops, it's a live stream. Okay, so I think at that point we're about ready to end it and move over to the home bases. Am I right, Juan?
Yes, you're exactly right.
Okay, let's do it.
Thank you, everybody. Awesome to see you.
Yeah, again, thank you, everyone.